Woohoo! Welcome back. Today we're going to be talking about the multiplication of matrices. Woohoo! And the best way to start matrix multiplication is with the acknowledgement that what we're about to learn is really unexpected and weird. Multiplying matrices involves concepts that will be explained in linear algebra if you take it later on. But we can take a small peek into what's going on by looking at the expression. I'm not sure why Microsoft Word decided to space it like this, but you know, Microsoft Word was having a moment. We're just going to go with it. We can make space for spacing, even if it's a little weird. So we've got 3x plus 4y plus 5z, which we can represent with the matrix 3, 4, 5, right? We've done this before in the previous video. So we've got the coefficients of the variables. But the problem is this does not include the variables. So how do we do that? Well, and here I'm going to point out that this is already a done deal. This is something I'm telling you about, but there's not going to be any petitioning to have this changed. This is the way it is done. This is the way I learned it. This has been going on for a long time. So the way that mathematicians represent the variables is with a column. So we've got a row of coefficients and a column of variables. And when we multiply these two together, we get that expression. Thankfully, with the spacing all sorted out. And I go on to say, even though that might seem really weird, and it might continue to seem really weird, and until you practice it a bunch, it'll seem a little bit different. This is the way we perform matrix multiplication, using rows and columns together in something called an inner product. And again, we are just dipping our cute little toesies into this concept. And if you go on to linear algebra, this will all get expanded on and explained more. It'll be really fun. You definitely don't want to miss that. But for right now, we just want to focus on how the heck are we going to do this? So we continue. Each row in the first matrix is combined with each column in the second matrix, and that entry is recorded in the corresponding row and column. As usual, this description, although being absolutely correct, is also of very little value to most people. And I don't know why I feel compelled to say it first, but I do. So thank you. I appreciate it. And then I'm going to make a little note. And this note is really important, but again, I'm going to do some practice that will make this more clear. So first the theory, then the practice. Once we get to the practice, hopefully it'll all make sense. But because of the way matrix multiplication is defined, the number of columns in the first matrix must match the number of rows in the second matrix. So in other words, you must have, if you, for example, have a 3 by 4 matrix, you want to multiply it times another matrix. That matrix must be 4 by something. It doesn't matter what the second is. You have to have these matching numbers in the middle. So the number of columns has to match the number of rows. Okay, so the middle two numbers have to match or you cannot multiply. There you go. Okay, let's give it a try. As usual, I'm going to encourage you to practice. Pause the video, practice on your own, and if you're feeling frustrated, if you're feeling lost, reach out. Talk to me, talk to the tutors, talk to your friends and family. Let's have a whole matrix party. This is going to be fun. I know Neo would be in for a matrix party. We could have some matrix music. Okay. So, but no dancing until after we multiply. So let us multiply these two matrices. So the first thing I'm going to do, it's going to say what are the dimensions of the original matrices, and this is always a good thing to check first, because if you can't multiply, then there's no point. This first one has 2 rows, 2 columns. Second one also has 2 rows, 2 columns. And where is my magical, we'll go with green for today. Choose the red pen or the green pen, and I picked the green one. There we go. The 2 and the 2 match. so we can do this multiplication. So, okay. 1, 2, and 3, 4 are the rows. 5, 7, and 6, 8 are the columns. So, officially, this is what we're doing. Officially, we're doing 1, 2 times 5, 7, and then 3, 4 times 5, 7, and then we're doing 1, 2 times 6, 8, and then we're doing 3, 4 times 6, 8. And if you look at this, you start to realize, wait a minute, this is kind of looking like the distributive property. And no, it is not the distributive property, but it kind of looks like it, right? 1, 2 gets to go to 5, 7, and 6, 8 in turn. And then down below, 3, 4 gets to go to 5, 7, and 6, 8. So they take turns. These are each inner products. And we end up with multiplications and sums. So we multiply the 1 and the 5 and the 2 and the 7. So you're turning your head one way or the other. Basically, you go over the side of the waterfall and you fall down. Across and down, across and down, across and down. Okay. So over here, this looks like 1 times 5 plus 2 times 7. Here, 1 times 6, right? The first 2 plus 2 times 8. Down here, I get 3 times 5 plus 4 times 7. And for this one, 3 times 6 and 4 times 8. Okay, so because I'm interested, I made it a little too big, but let's see if I can squish this in. So I think I'm going to get 5 plus 14, 6 plus 16, 15 plus 28, and 18 plus 32. So all together I get 19, 22. Let's see, this one's 43, and oh, that one's 50. And there we go. And that's how to multiply these two matrices to get to this one. Now, to be fair, I have not told you why we'd want to multiply two matrices. But if you wanted to multiply these two matrices, this is how you do it. Now, a lot of folks looked at this and said, oh my gosh, this is unbelievably, kind of stupidly hard. And so then someone came up with this, which I really love, and I found it online, and I found it one of my colleagues was doing it, and it's been kind of a revolution. And so I thought I would present it because I thought it was very cool. So what we're going to do is, let's see, in a big matrix, let's see if I can get this right, I'm going to, on the rows, write 1, 2, 3, 4. So I'm going to write the rows here as an ordered pair. And then up here, I'm going to write the columns, 5, 7, and 6, 8. So instead of leaving them as a row and a column, I'm kind of writing them all as ordered pairs. And if you have a larger matrix, you could, of course, do ordered triples or, ordered quadruples, I guess. So here we're going to multiply 1, 2 times 5, 7. Now, I am using a funky method of writing this out. This happens to be the way I saw it presented. This is not defined in math, so this is just a shortcut. This is weird shortcutty math, so this is not official. But basically, this is 1 times 5 plus 2 times 7. And here, I'm going to get the 3, 4 and the 5, 7. And because that's this spot, so I get 3 times 5 plus 4 times 7. Up here, I'm going to get 1, 2 times 6, 8. So that's 1 times 6 plus 2 times 8. And then down here, 3, 4, and 6, 8. So that's 3, 4, and 6, 8. So that's 3 times 6 plus 4 times 8. Okay? And so if we take a look at this, we see we get the same results, but this is just a slightly different way to orient. If this makes more sense, if you find this easier, go for it. I don't think there's any loss of understanding. The only benefit to doing this version that I first introduced, where you row off the side of a cliff and then you fall down the waterfall, is that when you do it that way, you will be doing it the way that a lot of your professors are doing it, and you'll be kind of following that mainstream way of doing it. So the benefit is this is going to be a little funky, and you might have to explain to people what you're doing, but I think it's pretty cool. And I'm a big fan of anything that will help you understand better. Of course, when we multiply out, 1 times 5 plus 2 times 7 is still 5 plus 14. This is still 6 plus 16. This is still 15 plus 28. And this is still 18 plus 32. So we do end up with exactly the same product. We get 19, 22, what was that? That was 43 and 50. We still end up with exactly the same product, but it is a slightly different method. So, woohoo, I encourage you to practice this, especially if you're going on to linear algebra. This is going to be like learning your times tables. The faster you can get, the more confident you can get about these, the more comfortable linear algebra will be for you. So that's why we're presenting it early. So as you move through math, you can build those skills. So, definitely start practicing and ask lots of questions. If this method works for you, great. If the previous method works for you, great. If neither of these makes any sense, I encourage you to go on the web, ask me, ask tutors. We all have other little tricks we use, and I'm sure there are other people online who've created some really interesting ways to do it. So I encourage you to consider lots of different options here. The bottom line is I really hope that we all find a way so that you can multiply these matrices comfortably and feel confident in your math, because then we can go on to the next step. Okay, woohoo! In the next video, we're just going to practice. So, until then, get some snacks, get some exercise, get some fresh air, and, know that you are amazing and incredible. Woohoo, and math on.